Um, Hello guys. This is third lecture for general physics, and I would like to talk some more math because the mathematics are very important, and we first deal with algebra for equations, and second for basic trigonometry, and this is vector is actually on some continuous version of trigonometry, but it doesn't teach you, I don't think it teaches you well in trigonometry or pre-calc class. So I had to go over this because a lot of physics equations, such as power equals to F, you see these notation, vector notations, velocity, force, you don't have to know this yet. You shouldn't have to know it, but I'm just showing you some several physics equations that you're gonna deal with. So this is called dot product, which you gotta know, but doesn't teach you in pre-cal. This is actually AP Physics C or General Physics class teach. So you need to know some basics of, this is called momentum, or this can be represented as I omega. So you have these like math notation, or if you go electricity, you have something called very famous law. You don't have to know it yet, but the force of E is presented as 4 pi epsilon, or what's it, Q1 Q2 divided by R squared, or E. You see these like vector. This is not an epsilon. Like you see these like notations. Like it's hard to you like algebra or if you just learn like high school math, you didn't learn these vector notations. So I had to go over the basics of vector and this little bit of linear algebra. It's not super hard. I'm just going to teach you some basic like dot products and cross products. I'm not going to teach you the every theory, like it's not necessary cross product. But you gotta know it because a lot of them, this is in dot product, this is in cross products, and Fm is QV. This is also in cross product. You don't have to know these equations yet. I don't have to know yet. I just wanted to show you some example of mathematics needed because you gotta know these equations more in depth, right? So you gotta know vectors and linear algebra, just basics, just not like super hard. Like you don't have to like know the theory of like independence or stuff like that, or yeah, I think you don't have to know like super in depth like how to like you in linear algebra you saw tells you about like determinants, independence, and stuff like that. I'm not going to go over those like math theory, but I'm just going to teach you some basics dot product and cross product you'll probably need in general physics class. So that's it. So let's go over some today's syllabus. This lecture might be long. I don't know how long it will take. I hope it doesn't go long. I want this lecture to be short, but first we're gonna go over what is vector, and we're gonna go over addition and subtraction of vectors. Like vectors can be added and subtracted, and some associative like property of those kind of stuff. And we're gonna deal with some polar coordinate. When you deal with a lot of vector system, a lot of them might be in polar coordinate. So we're just gonna learn the basics of how to calculate magnitude and direction of these vectors. And we're gonna convert these polar coordinate to rectangular coordinate. And then we're gonna multiply vectors by scalar, and we're gonna talk about some basics of unit vector, and we're gonna talk about basis with vector. This is also called as like I, J, K. It's just don't get scared. It's just like basis vector. And then we're gonna go over some basics of linear algebra, what is taught in linear algebra, and also you probably kind of learn in algebra class about determinants. We're gonna go over dot product, determinant, cross product, which is like in this equation is like this is in dot product and this is in cross product. Like you gotta differentiate between these two, right? So I'm gonna teach you the basics, and I hope you don't like. I think a lot of students gets a lot of problem with mathematics because physics. I mean, it is a science class, but a lot of them need like physics needs a lot of mathematical knowledge because a lot of formula is represented in numbers and you gotta know some equations and stuff like that. I know it's science class, but math, it's important. Even though you're just learning physics, you're gonna feel like you're also in a math class. So these are some basics, so let's go over. I'll teach you first of all what vector is. So I want to tell you the difference between scalar versus vector. Scalar is like quantities that has magnitude. Right? It's also same. Vector also has quantities. Well, it has magnitude. But vector has direction. But scalar don't. Direction? No. Examples? For example, time is magnitude. It doesn't have a direction. Or mass. Or like how many phone is in there, like there's 3 phones. Those are like scalar values. Vectors or like velocity. Velocity has actually vectors, like it could go velocity and this 10 meter per second, or you can have like velocity in this meter per second. Like you don't like it has a vector. The scalar version of the scalar version of velocity is actually speed. Speed is actually in magnitude, but this one has the direction. Also acceleration, or or force has a direction. Vector. Oh, there are so many, but I know many of you didn't take physics class yet, but a lot of them with directions have magnitudes. So what is vector? Oh, actually, I'll go to the next page. Vector. That is just magnitude and direction. Pretty hot in here. I'm just gonna turn on the air conditioner now. So let's say, for example, we have a point in P. And let's say this is 2 and 3. And we call this as origin, or O. I'll call this as origin. Then O of P can be also represented in 2 and 3. So we just represent it like this. Very simple, right? So it can be represented in x, y, z coordinate. For example, it can be written as 1 to -1, like a row. or as a column, like x, y, z, 1, 2, -1, like 2.69, -1.2, or something like that. So these are vectors, like this is how you represent it, and this is in, yeah, just rectangular coordinate, and it's not that bad, right? So let's go to the next lecture. Addition and subtraction of vector. I hope you can see this well. Yeah. Let's say we have a graph like this, and let's say we have A is equal to 2 and 3, and B is equal to 4 and 2. So let's mark this B first. 1, 2, 3, 4, 1, 2. Let's say this is B. And let's say 2. 2 is 2. A. Then what A will represent is this will be A, right? A, or origin to A, but I'll just skip that part. You can call it as O of A, or we can just call it as this, B. And we can add this up, A plus B. And how we calculate is, you know, A is 2 and 3 plus 4 and 2. Only the x part, you added this part. 2 plus 4 is 6, and 3 plus 2 is 5. So you have this theory. So how this works is that, let's say you have A and you want to add by 4 and 2. And what you do is, let's think this is as an origin, and 1, 2, 3, 4. So 1, 2. So because x has a 4, 1, 2, 3, 4. Then we have this, and 1, 2. So we have this value here, like this is a B. So if you add this up, and let's say this is equal to C. C equals to 6. But it also has associative property, which is A plus B is equal to B plus A. Let's do the same thing. B is here 4 and 2, and let's say it's 2 and 3. So 1 and 2, right? 1 and 2. Then y has 3 part, 1, 2, 3. So we have like this. So we proved that it has an associative property, right? And there's also a subtraction. I'll show you later. Let's say we have the same value, but let's say we want to do A minus B. A minus B is also equal to A plus minus B. And what is B multiplied by minus 1 is also equal to minus B. Then B is 4 and 2, right? Well, we can see this well. Then B multiplied by -1. -1 multiplied by B is 4 and 2. So it's -4 and -2. So let's draw this -4. 1, 2, 3, 4. -4. 1, 2. And we have this negative B, like this. And we just add A to it. So it's A, 2 and 3. So 1, 2, 1, 2, and 1, 2, 3. Like this. A. So this part is called A minus B vector. This is how you do addition and subtraction. Yeah, I think this was simple, so let's go to the next one. I think I need more paper. Give me a second. Yeah, I need some more paper. Yeah, I hope I'm gonna probably edit this part. It took some time. And we talked about addition and subtraction of vectors, and now let's talk about magnitude and direction of 2D vectors in polar coordinate. What is polar coordinate? It's by definition it says it's the two-dimensional system in which each point is determined by distance and angle from reference point, which is just if this one is Cartesian, just originally Cartesian coordinate, polar coordinate is represented as like this. And let's say we have a graph like this, and let's say let's say this is A is equal to 2 and 3. And we have a vector like this, right? We want to represent this, let's say we want to represent this by polar coordinate. How do we do this? We know that this is right angle, so we can use Pythagorean theorem, right? Like r squared equals r squared, x squared plus y squared. So r is equal to square root x squared plus y squared. We told you in trigonometry video, right? Pythagorean theorem. And we know that y over x is tau is tangent theta. So theta is tangent, inverse tangent of y divided by x. So how we're gonna represent this r is theta, like this. It's equal to x and y. Or in this example, we say this is 2 and 3, and then this will be 2 squared plus 3 squared. And this will be inverse tangent of 3 over 2. This is the polar coordinate, how you represent it. I want to do various examples, so let's go to the next one. Let's say we want to convert, next one is conversion from polar coordinates to rectangular coordinate. let's say this is r, theta, and we know that x is r cosine theta, because x represents r of x. It's just projection. The projection of r cosine theta, x value is r projection, x is r cosine theta. I told you in trigonometry lecture, because you know cosine theta is equal to opposite adjacent divided by hypotenuse. So ka. So it's adjacent is x and hypotenuse is r. So we know that x by multiplying r both sides r cosine theta. X. Y is equal to r sine theta. You know that sine theta is like this, so we multiply each side, so r sine theta equals to y. So what we can do is, let's say r is x and y, and this is also equal to r cosine theta and r sine theta, right? We know this fact and we learned this, so I hope you took a lecture, took a note. So I'm gonna do one simple example of this equation, right? Let's say we want to example 1, find 2, this is in polar coordinate, right? 220, 450 degrees. So this is just like, let's say this is 20 degrees, and this length is like 2, and 450 is like, this degree is 50, and this should be longer, right? So this is like 450, and let's say we add this up in polar coordinate. How do we do this? First we let's change it to rectangular coordinate. We know that as I told you here, this formula, we can use x is equal to, I'll write this again, r xy equal to r cosine theta r sine theta, right? So r cosine theta is 2 cosine 20 and 2 sine 20. This one comes out to be, I calculated before, 1.88 and 0.68. And 450 is equal to 4, using the same formula, cosine 50 and 4 sine 50. So this one equals to 2.57 and 3.06. Alright, so if you want to add this up, 20 plus 450, this one equals to, you know that 220 is equal to this in rectangular coordinates, so 1.88, 0.68 plus 2.57, 2.06. So this one is equal to 4.45. You just add this up by vector property, x and x and y and y. So this one becomes as 3.3748. And using that, we know that r is equal to x squared plus y squared with Pythagorean theorem, and theta is tangent minus 1 is y over x. As I told you in this lecture, we know that r is equal to this, and tangent theta is y over x, so theta is inverse tangent of y over x, right? So you gotta calculate this too, right? So R comes out to be plus using this one, and theta is equal to inverse tangent. You can just use this calculator, right? Use calculator, please. Like, engineers made it, so, and you guys can use calculator, so, and so this one comes out to be 4.818, and this one comes out to be 40.106. So the answer is, so the answer to this one, 220 plus 450 is equal to 4.818, 40.106 theta. Like this. So this was a conversion from polar coordinate to rectangular coordinate, and we did addition, and we can do subtraction, and that you can do like your own. It's a similar mathematics, just change to rectangular to addition, and then change to polar coordinate, and then after you find this coordinate, you can just use this as an answer, or you just change to polar coordinate again using this r equals to square root x squared plus y squared, and theta is equal to inverse tangent of y over x. Right. So multiplication of a vector by scalar and unit vector. Let's say a is 1 and negative 2. Then 3a will be a multiplied by 3, and this will be 3, 1, negative 2, so this will be 3 and negative 6, right? And 0.5a is 0.5a, so 0.5 on negative 2, so this one comes out to be 0.5, negative 1. You just multiply each side. You multiply vector. And I want to talk about unit vector. This is very important. This is represented R like this, and this one call it as you need to know this unit vector because it tells you also this. You have this R and you have this theta, right? R theta it is actually just cosine theta and sine theta. So what this one tells is just the x value and y value in angles, right? So for example, if you multiply r times r, then this one becomes r cosine theta and r sine theta, which is also equals to x and y, as I told you in basic trigonometry. And then let's do some calculations on how to do unit vector. I think we can use this space here. Unit vector, let's calculate unit vector of a equal to 1 and negative 1. First, we have to find this. This one is just x plus y squared, right? So we do 1 squared plus negative 1 squared. Negative 1 squared is just 1, right? So it's 1 plus 1, so this is 2. So unit vector is 1 negative 1 divided by square root 2, or it could be represented as 0 if you divide by this each side, because remember we can divide this by 0.5 and stuff like this. Using this fact, we can divide this by both sides, so we get this negative 0.7. Without the, let's do the same example. Find unit vector of b equal to 3 on 4. First, how to find unit vector? We need r. Unit vector is r divided by r. So in order to find this, we need to know r, this one is equal to x plus y squared. So other example is 3 squared plus 4 squared, and this one is just equal to 5. So r divided by r, this one is equal to 1 over 5, 3.4, 0.6, and 0.8. This. So the significant part, we found out that unit vector of a of 1 and negative 1 is 0.707 and negative 0.707, and also B4 is 0.6 and 0.8. This one is actually just an angle of I said this one is equal to cosine theta and sine theta, right? So what this represents is that when you have an angle like this, r and theta, just this, what this will represent is adjacent divided by hypotenuse. So what this one represents is adjacent divided by because this is cosine theta, and what this one represents is SOHCAHTOA, sine theta, because so basically it's just 1 over square root 2, and this one was negative 1, so it's negative 1 divided by something like this. So what this one is just this, and you can just find it using r divided by r. You don't have to use it this way, but as you know, in physics, a lot of problems will be solved in mathematics. All right. The more tools you know in order to solve these, more effective and more accurate the answer will be. So the many different ways to solve the problem will make you sure the answer is accurate and right. So this is one of the example how you can find cosine and theta and sine theta using like stuff like this, using unit vector theorem. Alright, let's go to the next one. Basis vector. What time is it? 34 minutes? Okay. basis vector. This is just easy one. Let's say this is x, y, z coordinate. I is just 1, 0, 0. J is represented as 0, 1, 0. And k is represented as 0, 0, 1. And let's say we want to represent 1 minus 1, 2 in basis vector. We know that this one is also equal to 5, 0, 0 plus 0, negative 1, 2 plus 0 and 0, 0, 2. Then we can also factor this out. 5 to 1, 0, 0 plus negative 1, 0, 1, 0 plus 2, 0, 0, 1, which is 5a minus j plus 2k. So this is just a basis vector. You represent some numbers in ijk. Don't get scared. I wanted to show you this because many physics problems like ask your question in this fact, like with this notation. I just don't want you to get scared of this notation, so I added this part really quick. This one is pretty simple, so just know that I is just x1 of x1, 0, 0, j is just 1 of y component, k is 1 of z component. I think that was simple, and let's go to the product. This one might get hard. This one is a little bit of introduction of linear algebra, but it's very important. Product of vector dot product, also called as scalar product. How you represent A, B, and let's say A is represented A1, A2, and let's say this one is represented B1 and B2. The dot product will represent is A1, B1, just multiply this one side, and then add A2 and B2. It's just same thing. It's just what this dot product is saying is it's just a scalar product of this these two vectors. Just it's a scalar product. It's just you multiply the x coordinate each side and add up with this y coordinate side each side. You multiply x coordinate of these two vectors and then add up with this y coordinate of these two sides. So let's say we have a two vector A, let's say C is equal to 2 and 3, and D is equal to 1 and 2. Let's say D dot group, calculate C divided 2. Then this one will be 2, 3, 1 and 2. So A1 and A2, this one. So it's 2 plus this one, 6, which is 8. Right, so I wanna now tell you something very important. Equation called A dot product, whatever I told you here, is equal to A, B, cosine theta. What this one represents is that or cosine theta is A dot product of B, A, B. Let's say we have A as 2, 3 here. And let's say we have A and B as 1 and 2, like this. Then what is the length of it? This one is just 2 squared plus 3 squared, right? And B is squared plus 2 squared, right? Using Pythagorean theorem, right? Then what it tells is that the addition, we find out in here that 2, 3 and 1, 2 is 8. So we're saying that A multiplied by the dot product of 8 is 8 divided by square root. This one is 4 plus 9, right? 4 plus 9, which is 13. Multiplied by this one is just 1 plus 4, so this is 5. So this one is equal to cosine theta, which kind of makes sense because you have this A and B. Let's say we have A and B, and you have this. Let's say this is X and Y, and let's say we have an angle like this. If you multiply X and Y by this cosine theta, then we also project this one as the same X value, so it's just X, Y, cosine theta. So it's hard, so it's just what this A and B represents is that it's this, let's say we have this okay, no, A, B, C, D, E. Let's say this is E and this is F. Then what dot product represents is that is the E and F, but in the same side let's say this is the X coordinate. We project this as cosine theta and we just multiply by E. This is what A dot product B actually represents. I'll show you more example. Let's say let's say we have 2 and negative 1, 0.5 and negative 1. And let's call this E, F, G, and let's call this G and H. And let's try to find the cosine theta of this value. This one is 2 and negative 1, so 1, 2, negative 1, so we have G, this is G, and this one is 0.5, negative 0.5, negative 1. We have like this. If you take dot product of this, I told you that A is this formula, then you can tell that this one is 2 multiplied by negative 0.5. Oh, sorry. 2 multiplied by negative 0.5. Addition of this one, negative 1 multiplied by negative 1. This one is just negative 1. And this one is just 1, right? Multiplied by negative 1. Negative is just 1. equal to 0. If you see this part, so this one is 0. Why? It's because you know that AB is and if you see this graph more magnified, it has a, let's say this is 0.5, 1, 1.5, and let's say this is 2. We have a G. We have a G that sticks out like this, and we have an H that sticks out like this. We call that A dot G dot H is G H cosine theta. The thing is, this is right angle. What's cosine theta of 90? This is 0. That's why G of H was 0. So if the dot product is 0, we can rightly assume that this one is right angle, which is also called as orthogonal or normal. So if the dot product is 0, it's a right angle. We'll do one more example. If you wanna assure that this theorem is correct. Let's say we have 1 and negative 1. We will point in here, and let's say this we did H, right? I, J, K, L, L. Let's say this is L, and this is 1 and negative 1, right? We will vector like this, M, and we have M. Also call this negative 2 and negative 2. In my theory, I think the dot product of this one will be 0 because I think this is a right angle. And let's try. We know that L dot M is equal to R1 M1 plus L2 M2, and this one is negative 2, and what's R1 M1 is this negative 2, and negative 1 and negative 2 is just 2, 0, right angle. Right, so just remember this, like A dot product of B, A, B, the magnitude of A and B, cosine theta. A is A squared plus A1 squared, A2 squared, and B is just, let's say this is X in XY coordinate. Does it fact? Right. Okay. Last one and the final boss. Cross product. Before there's so many papers here. So in here, I think I told you some dot product fact. So this one is actually also can be represented as f t cosine theta. And this one can be also torque as can be also actually this should be in, give me a second. Actually, yeah, sorry, remember, yeah. This one I didn't talk you about. This should be X. This is cross product. So this one actually can be represented as like this. But now we gotta talk about cross products. So before we talk about cross product, we gotta talk about determinants. Let's do some prove some determinant. What is determinant? Determinant is area of parallelogram. We call it as, let's say, okay, I'm gonna do some math here. So this area. So watch it carefully, okay? Let's say there's an AC, okay? There's a vector called VD. A, it's A, this is X part, and C, you have this vector, right? And for BD graph, let's say B is here, and D is here. So BD graph will be, looks like this. Then let's say this one, we add AC from this part. So how do we draw this part? So starting from B, and then we add by A. So let's say this one is just A, and this one is C. So we add this AC vector from this origin, and the same thing from this origin, we add this by B dot D. Then we have this graph like this. We know this, that this part is A, right? And I want to find the area of this part. How are we going to find it? We know this is A, this length is A, and we know this as a Y component, this is C, right? But since this is right triangle, we know that this is AC by 2. And same in here. For this part, we know that this part is B. And we know that this length is D. So we know that this one is BD divided by 2 because it's right angle. And we know that this part is just we remember we add this part here. So this part should be B, right? Because this is an X component. So this one, the area of here will be C. Same in here, we know that this part is this part, and we add this Y component by C, and this one was just B, so this one is BC, right? And we know that this length, the amount of this is also, let's call this AC here too, BD here too. We know that this part is A. So we know that this area is AC divided by 2. I think this is too large, then I'll change it to this. Fine. Yeah, I've been using this one, so. And we know that this one is B, and we know that this is D because we added, actually this is BD, right? So it's BD divided by 2. So what is this area of the triangle, of this parallelogram? First, we know the whole area. This is A and this is B. So we can do A plus B. This whole area of this X part is A plus B. And we know that this part and this part is just C, and then we add it by AC, C, and we add it by, since we know that we added by C, we know that this is also C. And we know that this is D. So it's D plus C. And we can just subtract this area, right? So we can subtract this by AC divided by 2. We subtract this part, and we just subtract AC divided by 2. Right? Minus BD divided by 2. This is also BD divided by 2. Minus, this is BC, and this is also BC. So 2BC, right? So let's make this is big. So A can you see this row? AD multiplied by this is plus AC. This one is BD plus BC. This one is just minus AC divided by 2 and minus AC. What's minus AC into 2? This one is just minus AC, right? You get this part? You AC divided by half, and then AC divided by half. So this is just AC. Or what you can do is 1 over half. You factor this 1 over 2 divided by half, and then this will become AC plus AC. So this will be 2AC divided by 2 negative. So this one just became negative AC. And this one same is become negative BD minus 2BC. So this would be area of parallelogram of AC and BD. Right? Then we can cancel this one out, right? This one out, right? And AD BC was minus 2BC plus BC minus BC. What is this? This is called determinant. Determinant of the vector AC in here and BD here is AD minus BC. That's why we know that the area of this part is AD minus BC. So by law, these two vector 1, vector 2, the area is AD minus B. We proved it for any vector as AC and BD. So we proved that for two-dimensional vector, the equation for these two parallelogram, these two vector, when it becomes like a parallelogram, the area will be AD minus BC. Okay, this one was hard topic, but this was a proof. I wanted you to understand what determinant means. Determinant. And I proved it here. So make sure you understand that the area of this parallelogram of this AC and BD is AD minus BC. So I continue to cross products. The last part. Cross product. Cross product, I needed to tell you what determinant is in order to talk you about the cross product. Cross product is B is a vector that is perpendicular to both A and B, which is normal with determinant or area. I'll show you this example. Let's say A is 7, 0, and B is 4 and 3. A is 0, so we have a graph like this, and B is 4, 3, so we'll be around this. And using this proof, we know that if we make a graph like 7, 0, vector 1, vector 2, 4, 3, and let's say this is x and y, and we know that determinant is AD minus BC, which is also called 21 minus 4 multiplied by 0, which is 21. Or we can know that just this right angle part, just this 3 part, we know that if we know that this is 3, then we know that area of the parallelogram is just this times this, right? If you learn in some geometry class, we know that 7 times 3, if this is parallelogram, this. But this is just extra, BC, this one tends to be 0, so this one just became 0, so that's why it just became 21. So this is determinant, but what this will do is that if you have equations like torque goes, I'm going to tell you in electron. I know I didn't tell you the concept of electron yet, but what this one represents is electron moves in, if electron moves in this direction, and the buoyancy, the magnitude is acting this way, then the force representing is this way. Or this can be also represented as QVB sine theta. So this one is what sine theta represents, and this one, what this sine theta represents is just determinant of this too, so it's AD minus BC. So it uses a lot equations like this, or also torque is equal to R times S, or also can be represented as F RF sine theta. So I think I showed you in here, physics equation use a lot of cross products. This can be also represented F or sine theta, or RP, R momentum sine theta. So I think and QVB sine theta. So this one was what cross product is. It was just a little bit introduction to linear algebra, but I don't think it was super hard. But I think this is just the basics of some vector notations that you gotta know for physics class. Thank you very much.